but don't look down.
'Cause I'm on top of the world, eh? I'm on top of the world, eh? Waiting on this for a while now, paying my dues to the dirt. I've been waiting to smile, eh? Been holding it in for a while, eh? Take you with me if I can. Been dreaming of this since a child. I'm on top of the world.
I've tried to cut these corners, tried to take the easy way. I kept on falling short of something. I could have gave up then, but then again I could.
We'll start off with the definition of a derivative. This symbol here is a notation for the derivative, and the equation is as follows. The limit as h goes to 0, f of x plus h minus f of x all over h. So, what does it mean? Here's an example. Find the derivative of f of x equals x squared minus 3x plus 1. First step, write the limit of h as it approaches 0. Be sure to write this every time because it is crucial. Here's what your problem would look like. If you're confused, just plug in an x plus h wherever you see an x in your original equation. Step 2. FOIL out your numerator or expand it if you will. Step 3. Combine your like variables to make the problem easier to read. Step 4. Eliminate h from your denominator like so. And you get 2x plus h minus 3. Notice how the limit is still in the problem. Step 5. Plug in a 0 for h. And notice how when you plug in the limit, you don't have to write it, but only after you've plugged it in. After plugging it in, what you're left with is your slope. To define derivative at this point, just plug in into your slope. For example, at x equals 2, your derivative is 1, and at x equals 0, it's negative 3. Now, we'll identify the different derivative notations you'll see throughout calculus. First looks like a y with an apostrophe. That's y prime. Next is the dy over dx. This means that the derivative of y with respect to x. Next is df over dx, which means the derivative of f with respect to x. Lastly, we have a d over dx multiplied by an f of x, which means the derivative of f at x. So, find the derivative of f of x equals x cubed. Set up the limit of h as it approaches 0 and substitute the x plus h for x in your original equation. Then FOIL out your x plus h cubed. Combine like terms to get the limit of h as it approaches 0, h squared plus 3h squared x plus 3hx squared all over h. Then cancel out h's to get h squared plus 3hx plus 3x squared. Finally, plug in 0 for h, and your solution is 3x squared. We already learned one definition. This works the same, and the equation is as follows. F prime of a is equal to the limit of x as it approaches a, f of x minus f of a, all over x minus a. And just like the other one, you plug in a for x. Here's an example. Differentiate f of x equals x squared minus 2. The first part, f of x, stays the same as your original equation, and for the second, the f of a, just substitute for x in your original equation. Just like the other equation, add the like terms. And notice how the numerator can be simplified by factoring. Once factored, cancel out the x minus a, and you're left with x plus a. Notice how the limit of x as it approaches a was left in the whole problem until you plug in a for x here. Your answer is 2a or 2x. That is your derivative. We'll now analyze and learn to graph an f-prime graph from an f-graph. Start off with the original function and always label your graphs, as shown. This is our graph. There are two linear sections with one positive slope and the other negative. The slopes are shown here for the two sections. Now draw your f-prime and don't forget to label your graph. You know the placement of your f-graph because if your f-graph is linear on both parts and meet at the point 1, 1. The slope of your first half is 1, so there's a horizontal line through y equals 1 on your f-prime graph, until 1, 1, which is where your f-graph decreases with the constant rate of slope of 2. So from 1, 1 and up there is a horizontal line at y equals negative 2. If your f-graph is decreasing, then you know your f-prime is below the x-axis and vice versa. Now, we'll go over the left and right-hand limits and how to find them. You've seen and noticed this equation, but there's one small difference. This plus sign indicates that the limit is from the right-hand side, while this minus sign indicates a limit from the left-hand side. Here's what they look like. This is your graph, and here's the limit from the right side only. Look at the right side or increasing values if there are any. Here's the limit from the left side.
Sing like, ooh, so what you wanna do? Let's just run.
Find the derivative of y equals 2x at x equals 2, negative 4, 0, and pi. Solve the problem by substituting x plus h in for x, and don't forget to put the limit. FOIL out the problem. Then simplify by adding like terms, keeping the limit until you're ready to plug it in. Cancel out the h and you're left with 2 as your answer, since you have nothing left to plug in. And since you have no variable, 2 would be your answer for all those points as well. Let's do the same thing with the square root of x. Set up the problem the same way as the other one. The only difference is you have to get rid of the square by multiplying by the conjugate. The conjugate is the same equation, but with a sign change. Now, multiply the equation and add like variables and cancel out h to simplify. Next, you'll plug in your 0 and simplify again to get your answer. Lastly is to test your points. Using your 1 over 2 root x, of course. For x equals 2, you get 1 over 2 root 2. Negative 4, you don't get an answer because you can't take a root of a negative number. 0 does not exist because you cannot divide by 0. And pi gives you 1 over 2 root pi.